Hi, good day, and welcome to the Division of Education, Innovation and Energy e-learning program. I'm one of your maths facilitators, and today I will be exploring factorization. My name is Joseph Frederick. We want to look at the first method of factorizing. And for this method, we are utilizing the distributive property. So what we're saying is this, that for any algebraic expression that you're asked to factorize, in the exam, in question number 2, they usually ask you to factorize algebraic terms, or algebraic expressions, I should say. Any algebraic expression that you're asked to factorize, the first thing that you do, is to utilize this method. Check to see if this method applies. It may not apply, but you need to check. When factorizing, the first thing is we evaluate the expression to determine if a common factor exists. If a common factor exists, so that's 1. 2, let me just change the color of my pen. 2, if a common factor exists, we write it down followed by open brackets. All right, that's 2. Seems like it's making sense to me now. You know, sometimes when you're reading a problem and you don't fully understand what is taking place, my advice to you is just try to read it again. Yes, do a little recap, read it over, and it may make a bit more sense the second time you're reading it or the third time. So that's my suggestion. So we are saying, check for common factors. If common factors exist, write them down, and we then determine what must be multiplied by the highest common factor to give each of the original terms. Whoops, here we have an expression. This expression is 6x cubed plus 9x squared. Here we have 2 terms. We have the term 6x cubed, and we have the term 9x squared. Now, it's important here. Remember, we spoke to it in multiplication. It's important when you're writing the terms, you write the terms with their signs, positive or negative. And when we were doing integers, check the video on integers. When we were doing integers, we said that if I see no sign in front of a number here, if I see no sign in front of a term, then the term is positive. And we also said that the operation, the sign operation that comes between your terms, that sign operation is assigned or is given to the number that comes after. In this case, it's the term that comes after. So this positive sign, hello, 9x squared, you need to take that. Yes, so this is positive 9x squared, positive 6x cubed. So we're factorizing it. Let's go back to the steps again. Step 1, when factorizing, the first thing we do is to evaluate the expression. Here is our expression made up of 2 terms. Evaluate the expression to determine if a common factor exists. So let's check that and see. My terms, 6x cubed, 9x squared. Do we have a common factor? How did we do that again? We started from the leftmost term and we looked at its coefficient and went in. So it's here, 6x cubed, coefficient is 6. Coefficient for the next term is 9. Do we have anybody common there? Is there a number that can divide both 6 and 9? Of course, you're correct. There's one. That number is 3. So it's 3, contributor to highest common factor. I have x cubed and x squared. Next, is there a common factor here? Well, for sure, both of these terms have x. So then the contributor to the highest common factor is going to be the one with the lowest power. The lowest power here is x squared. So my highest common factor here is x squared. What do we do next? Let's see. Well, I got that right. Highest common factor is 3x squared. What do we do next? The next thing we do is that we say here's what. So the highest common factor is 3x squared. What can we multiply 3x squared by to give us 6x cubed? That's my first term. So according to us here, let's go it over again. Let's go over the steps one more time. When we are factorizing, the first thing we do is to evaluate the expression to determine if a common factor exists. If a common factor exists, we write it down followed by open brackets. And we ain't get there as yet. But we're still doing a little analysis. When we then determine what must be multiplied by the highest common factor to give each of the original terms. So my highest common factor here is 3x squared. What are my original terms? My original terms are 6x cubed. And my original term is 9x squared. So those are my original terms. So the question we need to answer here is this now. What need I multiply 3x squared by to give us 6x cubed? Remember when we were doing multiplication, what we said? We said that when we are multiplying, we need to add the exponents. Now here, what do we have re-exponents? We have an exponent for x, we have an exponent for x. So here what we're asking ourselves here now. This is what I need to multiply to get that. So what number, because when I'm multiplying I add my exponents, what number do I add to this exponent to give me that exponent? The number that I add is, correct is right, it is 1. So here in terms of my variable, it is going to be x to the 1. But I'm not finished because I have coefficients. So I need to work my coefficients as well. 3 multiplied by what is going to give me 6? 3 multiplied by, correct is right, 3 multiplied by 2. So this is what we're saying here now. That 3x squared multiplied by 2x gives me 6x cubed. Remember the laws for multiplication. Multiplication is commutative, so I can rearrange and still multiply. 3 times 2 is 6. X multiplied by, x squared multiplied by x is going to give me, add the powers, x cubed. Are we correct? Bingo, we are correct. Oh, I'm blocking you. Sorry, I am blocking you. So we had 2x, and it is 2x. Nice. Look at this one now. So here, this looks interesting. Here, in terms of my variables, the power here is 2, and the power here for where I want to get to is also 2. So the question here is now, what power do I add to this 2? Ooh, I'm blocking you. What power do I add to this 2 to give me that 2? What do I add to 2 to get 2? Nothing, right? So this here should be x to the 0th power. Remember when we were doing, I gave you some initial laws for working exponents or exponential laws. And I said that anything raised to the 0th power is the zinger. Anything raised to the 0th power is 1. So this here is, it's x to the 0, but we now know x to the 0 is 1. And we do our coefficients. So it's 3 times what gives me 9? 3 times what gives me 9? 3 times 3. So it's 3 x to the 0. Multiplication is occurring here. So this is really 3 multiplied by x to the 0 is 1. It is going to give me 3. So therefore, 3x squared multiplied by 3 is going to give me 9x squared. Is that what we have here? Correct is right. So now factorizing it, let's just go back to the steps. We said, step 2, if a common factor exists, we write it down, followed by open brackets. We got our common factor to be 3x squared. We then wrote it down, followed by an open bracket, and then we said 3x squared multiplied by what is going to give me 6x cubed? We got 2x. So we wrote down 2x. Then we asked ourselves, 3x squared multiplied by what gives us 9x squared? We got 3. So we wrote down 3. Close brackets, and we are finished. Let's take a break, and we shall be right back. So, factorization utilizing the distributive property. This is what we have. Let's look at something else again. Look here. What if we were asked to factorize this one? Factorize the following. 4a cubed b plus 8a b squared. According to our steps before, they said, scan the expression. We're scanning the expression. Determine if a common factor exists. Looking at this expression here, is there a common factor? You're correct. We did some of that before. There is a common factor. What is that common factor? And more so, what is the highest common factor? The highest common factor is 4ab. Is this correct? Let's check now. In terms of our numbers, what is the biggest number that can divide 4 and 8? 4. In terms of our a's, we have the lowest power is going to be a to the power 1, which is a, and in terms of our b's, it's b to the power 1, which is b. So our highest common factor here is 4ab. So 4ab is our highest common factor. The next question we need to ask ourselves is this. What can I multiply 4ab by to give me 4a cubed b? And likewise, what can I multiply 4ab by to give me 4ab squared? Sorry, 8ab squared. So here, 4 times what is 4? 4 times, correct is right. 4 times 1 is 4. I have a here. What is the power on a here? I have a here. So I know I need to multiply a by some a to a power to give me a cubed. This is a to the 1. When we are multiplying, we add our powers. So what need I add to 1 to get 3? It is going to be correct is right. It is 2. And likewise here, this is b. I have b here already. Yes, I could say that, or I could continue down that argument that this is b to the power 1. I need to get here b to the power 1. 1 plus what is 1? b to the 0. But remember, anything raised to the 0th power is 1. Multiplication is taking place here. So this is really 1a squared multiplied by 1. Anything multiplied by 1 is itself. So it's really 1a squared. Writing it like mathematicians now, rewrite it. This here is a squared. Let's see. Yes, correct. Oh, I'm blocking you. I am blocking you. So let's erase all of it, and it's a squared. So we are saying 4ab multiplied by a squared is going to give us 4a cubed b. What about the next one? So that's the first term. What about the second term? For the second term, what need we multiply 4ab by? What need we multiply 4ab by to get 8ab squared? What need we multiply it by? So we are saying that it's, do the analysis again. 4 times what is going to give me 8? 4 times 2. I have a here. I'm looking for a. I already have it, so I don't need to write it. Or we could do the argument again. A to the power 1 is here. I need to get a to the power 1. So what a need I multiply by here to give me this? This is 1. This is 1. When I'm multiplying, I add the powers. So 1 plus 1 is, 1 plus what is going to give me 1? 1 plus 0. Yes? Remember, anything raised to the 0th power is 1. Correct is right. Here I have b. And where do I want to get to? I want to get to b squared. So b by what b is going to give me b squared? This b here is b to the power 1. So I have 1, and I want to get to 2. 1 plus what is going to give me 2? 1 plus, correct is right. 1 plus 1. Now remember, anything raised to the 0th power is 1. So this here is 2 multiplied by 1b. And 2 multiplied by 1b is simply 2b. Let's see. Yes, we are correct. So therefore we are saying that 4ab multiplied by a squared is going to give us 4a cubed b. That's our first term. And 4ab multiplied by 2b gives us 8ab squared. 8ab squared, that's our second term. So based on what we would do, the steps that we were given, what we then do is that we write the highest common factor. What is the highest common factor? It is 4ab. Then we do open brackets, and we say 4ab multiplied by what is going to give me 4a squared, a cube, b. It is going to be a squared, based on our analysis here. And then we say positive 8ab squared is what we want, but what need I multiply 4ab by to give me positive 8ab squared? It is going to be 2b, so it's going to be plus 2b. Let's check and see. So they're factorizing the expression we get. Bazinga. This thing is nice. I told you maths was nice. The best subject that you can ever do in your life is mathematics. It's one of the most exciting things that you can ever experience. Why am I saying that's exciting? You'll see shortly. So factorizing, utilizing the distributive property. We're still on that. That's what we're doing thus far. There are basically 4 methods that I know to factorize. It's factorizing, utilizing the distributive property. It's factorizing, utilizing the method of grouping. Factorizing, utilizing differences of 2 squares, as you saw in our objectives, and factorizing a quadratic. We want to take us one class and work on factorizing quadratics. There are some shortcuts that I want to show you. So we're not going to do that this class. The next class we shall do that. The next video we shall do that. Right, so we're going. Factorizing, utilizing the distributive property. We still have another one for you to factorize. Can you look at it now and tell me the highest common factor? Bingo! The highest common factor here is what? Y cubed. Correct is right. So we are saying, if I have y cubed, what need I, let's see if we could do it without the chart. What need I multiply y cubed by? Where's my marker? Come here, marker. What need I multiply y cubed by to give me 3y to the 5th? Can you tell me? What need I multiply y cubed by to give me y fourth? What need I multiply y cubed by to give me negative 2y squared? What did I multiply that by? Let's see. Whew, let's go. Okay, so we want to get 3y fifth. What again do we want? We want to get y fourth. We want to get that. And we want to get negative 2y cubed. Remember we said signs are important. Here, the negative sign, we don't usually write the positives as you can see here. We don't usually write the positives. But the negative signs, it's important for us to state the negative signs. Important. Because the positive is understood. The negative, no, we don't understand that. We need to write it in. We need to write it in. So, what need I multiply y cubed by? You were thinking on it for a while. So, what need I multiply y cubed by to give me 3y fifth? Oh, correct is right. It is going to be 3y squared. Tell me if you see it. I need a 3. So, I'm going to have to put the 3 there. Because here, the coefficient here is what? The coefficient here is 1. So 1 times what gives me 3? 1 times 3 gives me 3. Here I have y cubed. I needed to get y fifth. So it's y to some power. Y to what power gives me y fifth? What power need I add to 3 to get 5? It is y squared. Right? So y cubed multiplied by 3y squared is 3y fifth. We go again. We need to get y fourth. So I know there's no coefficient here, so I know it's 1. So 1 is understood. I have 1 here, 1 is understood. What need I multiply y cubed by to give me y fourth? I know it's some y. What y? 3 plus what is giving me 4? Y to the power 1. So y cubed multiplied by y to the 1 is y to the 4th. And y to the 1 is y. Yes, it is not 0. Y cubed now multiplied by what gives me negative 2y squared. Now I have 1 here as my coefficient. The coefficient here is negative 2. 1 multiplied by what gives us negative 2? If you can't remember, check the video on our integers. 1 multiplied by negative 2 is negative 2. And y cubed multiplied by what gives me y cubed? I could say that I already have the y cubed, so I don't write it. Or I write my y, and I say 3 plus what gives me 3? Of course, 0. Anything raised to the 0th power is, correct is right, 1. So this is negative 2 multiplied by 1, which is negative 2. So let's see if we correct here. Yes, y, we got that y. Negative 2, we got that. So now that we have that, what do we do? According to the steps, what we first do is that we first write the highest common factor. Here's y cubed. Do some open brackets. Y cubed multiplied by what gives me 3y to the 5th? It is going to be 3y squared. And y cubed multiplied by what gives me y to the 4th? It's positive, so it's positive y. Y cubed multiplied by what gives me negative 2y cubed? It is negative 2. And we have completely factorized. Well, not necessarily. Based on what we know, we have completely factorized this expression here, based on what we know. Right, so here, factorizing the expression, we get y cubed. Again, we're utilizing brackets once we are using the distributive property. It is y cubed, not y3, y cubed, brackets, 3y squared plus y minus 2. And we have factorized it utilizing the distributive property. It can be further factorized. We shall show you in a later video. So, this is the most important slide here. Here's this. Mistakes are proof that you are trying. Anybody in mathematics, anybody who has succeeded in mathematics to some degree, knows that they will make mistakes as they work problems. A lot of students would usually say maths is hard because they tried a question and they didn't get the answer. Don't worry about that. That is part of the process. Mistakes are proof that you are trying. You must never give up. You never know how close you are. So never give up on your dreams. Hey, I know you have a maths dream. Don't give up on that maths dream. It's the most important subject that you can do. So let's get along with our factorization. So we have used factorization for the distributive we have used the distributive property for factorization. You wondered why I put that slide inside there? Because here, I have this problem for you. So take a try on this problem and tell me. So, we are back. How do we factorize this? I know you tried it, because my slide before motivated you some, did it not? Right, good. So I know you've tried it. So how do we factorize this here? The first thing that we do is to scan the expression to determine if a common factor exists for the terms. Here's a term. Do we have a common factor? We don't just want a common factor. We want the highest common factor. So in scanning the terms, we need to come up with the highest common factor. Yes, you're correct. You're right. We did this one before. We evaluated these terms before to determine the highest common factor. Can you recall what it was? Or did you try it? The highest common factor, look at your coefficients. It's going to be, so the HCF here, highest common factor here is going to be for the numbers, for the coefficients, sorry, it is 3 in your numerator. Remember, it's a fraction. It's an algebraic fraction. So, of course, you would need your vinculum. So, the common here for my coefficients, highest, is going to be 3. And then we scan across, look at your m's. Contributor is going to be 1 with the lowest power. Correct is right, so that's m. Look at your n's. The 1 with the lowest power again, so that's n squared. And look at our p's in the bottom. Our highest common factor here is 3mn squared p. Let's see if we got that right. Highest common factor. Woo! I'm blocking you again. So let's just give you a little chance to see that. Highest common factor is, that's what we got. Correct is right. That's what we got. So, now that we have that 3mn squared upon p, that's a mouthful, is our highest common factor, we then need to determine what need we multiply this by to get each one of these terms. What need we multiply 3mn squared p by to give us 9m cubed n squared p fifth? We need to get that. But also we need to get what need we multiply 3mn squared p by to give us what? You're blocking me here, man. Right. To give us 3m squared n squared p. And also, what need we multiply 3mn squared p by to give us 6m n cubed p cubed? Whew, that's a mouthful. Let's try that and see. It's not as difficult as it looks. Does it look difficult? Of course not. I know you like maths. Let's go with this. So, the highest common factor according to our steps, write out the highest common factor. It is 3mn squared all upon p, and then we open up some brackets. Boom. We then see now, let's look at our numerator. What do we multiply here now? 3mn squared p by to give us 9m cubed n squared p fifth. Working our numerators first, we are going to get, let me put my vinculum one time. Working our numerators first, 3 times what is 9? Correct is right. M here, so I need M here. M, right, M. So this M has a power of 1. This M, I don't know what its power is going to be, but this M has a power of 3. So I have 1, and I need to multiply it by some M to give me 3. When I'm multiplying, I'm adding the powers. So 1 here plus what is going to give me 3? Ah, correct is right, that is 2. I have n squared here, and I need to get n squared. What we can say is that given that I have it in the factor, common factor, and that's what I'm looking for in the term, then I don't need to write anything. Or we could do that analysis. That it's n here, so I need n here. This is n to the power 2. I'm going all the way to get n to the power 2. So what need I add to this 2 to give me 2? 2 plus what is 2? Correct is right. 2 plus 0 is 2. I have p here, now down to the denominator. I have p here. What is the power on the p again? Correct is right. It's p to the 1. And I have p to the 5th here. So, what need I add? Let me write my p here. What need I add to this power 1 to give me this power 5? It's going to be 1 plus what is 5? 1 plus 4 is 5. So here, this is 3m squared n to the power 0. But remember what we said. N to the power 0. Anything raised to the 0th power is 1. Correct is right. So this is going to give us 3m squared multiplied by 1 all upon p to the 4th. Which gives us really, anything multiplied by 1 is itself. It's 3m squared all upon p. So that gives us 3m squared all upon p. What's wrong with me? It's p to the 4th. I'm missing my 4. P to the 4. Come on, Marker. See, I made a mistake. I told you from time to time you make mistakes in mathematics. Did I not? That doesn't mean that you don't know mathematics or you can't do it. And from time to time my pen gives me trouble, as you can see. Right, so we're going. So the next one. 3m to the 1 n squared, that's what we have as our common factor. We need to multiply it by something to give us 3m squared n squared p. What need we multiply it by? Again, we do the same thing. Vinculum. Boom. We then go 3 times what is 3? Of course, that is 1 coefficients. We did that. M to the 1, I need my m here. So it's m to the 1 by m to the something. Gives me m squared. When I'm multiplying, I add the powers. So what power need I add to this 1 to get 2? Of course, it is 1. I have n squared here. I have n squared here. Oops, listen to me. Let's not forget. We did something like this already. Look on top here. N squared, we needed n squared. It was n to the 0. Anything multiplied by the 0th power is 1. We don't usually write that 1 in algebra. So we go. Let's do our p's now. So it's p to the 1. I need to put my p here. And I need to get, there's no power here. The power here is 1. So it's p to the 1 multiplied by what? P to the what, sorry, is going to give me p to the 1. Again, 0. Anything raised to the 0th power is 1. So this here is really 1m. We don't write the usually. We are playing mathematicians here. With time we shall be mathematicians. So we don't usually write the 1 as the coefficient. We don't usually write the power if it's 1. Yeah? That does not mean, however, that m is 1. Just remember that. So it's m all upon p to the 0th power. Anything to the 0th power is, I'm writing back p. What is wrong with me? I think I'm tired. Right. So anything to the 0th power is, correct is right. Anything to the 0th power is 1. So it's 1 again. I don't usually write the 1, so this here is m. Let's check and see. Yes, sir. I'm blocking you again. Just erase for you. So it is m, as you can see. Right? So 3m n squared p multiplied by m is going to give us 3m squared n squared p. Now we go for the last one. So again, this is my highest common factor. What need I multiply my highest common factor by to give me 6m n cubed p cubed? Correct is right. You got it right. It is 2n p squared. It would give me, so check it here. I already have my m's. So n squared by what is going to give me n cubed. P by what gives me p cubed. And we are good to go. So therefore, factorizing the expression here, we have 3m n squared all upon p, open brackets, 2m squared upon p fourth, plus m minus 2n upon p squared, close brackets. And we have completely factorized, this expression utilizing the distributive property. So we want to look, so what we have looked at so far in terms of factorization is we have looked at utilizing the distributive property to factorize some algebraic expressions. What else can we utilize for factorization? For factorization, we can utilize the method of grouping, the grouping method. Let's work in groups. Some people like it, some people don't. But here, in factorization, it's a very important tool. Factorizing utilizing the grouping method. Here's an example. Factorize 4a plus 4b plus am plus bm. Now, remember what we said. That whenever you are asked to factorize an expression, the first thing that you do is to scan the entire expression to determine if there is a common factor. Looking at this expression here, scanning through, do we have a common factor? I'm seeing 4 here, I'm seeing 4 here. But there's no 4 here and no 4 here. So here in common. A as well, not common. B, not common. M, not common. So what do we do? Here, what we say we do is that we factorize by grouping. So we look at the expression and identify terms that may be similar. Yes, once we have the same number of similar terms, we go to work. So here, we recognize that this has 4, this has 4. So we're saying that these here are similar. They would have a common factor of what? 4. Likewise, here, common factor of m. So what we do, that's the expression again, what we do is to group them. So we group those that have what we see as a common factor. In this case, that common factor is 4. And we utilize that same method again, factorizing, utilizing the distributive property. So since 4 is a common factor, we factor out that 4. It's the highest common factor here. So factoring out the 4, 4 times what is 4a and 4 times what is 4b. Similarly, we do it for the other pair as well. So it is AM and BM. What is common? Common here is what? M. So it's a common factor. We take him out. It's going to be M times what is going to give me AM? M times A. Remember we said multiplication is commutative. So therefore, MA is the same as AM. Multiplication is commutative. Order does not matter. Right? So once we have that there now, what we do now is this. What do we do? What we do, look here now. Here, what we have is this. We have 4A. The M here is positive. I didn't put in the positive, but the M is positive. It is 4 into A plus B plus M into A plus B. These here, what I have here are two terms. This is a term. This is a term. For this term, what do I have here? I have 4 and I have A plus B in brackets. For this term, what do I have? I have M and A plus B in brackets. Both of the terms has A plus B in brackets. So therefore, for these two terms, A plus B is a common factor. Utilizing that distributive property again, we are going to take out the common factor. What's the common factor? The common factor is A plus B. And A plus B was multiplied by what here? 4. A plus B was multiplied by what here? M. So it is A plus B into 4 plus M. And we have completely factorized it. How are we looking here? I like this. This is nice. Let's go down the road again. What about this one? Again, utilizing the grouping method, we still have to utilize the distributive property. So utilizing the grouping method here, this is what we have. X squared minus xy plus 5x minus 5y. Grouping based on what we see as common factors. So here, grouping. Now, here in our grouping, what we are attempting to do, let's just go back a bit. What we are attempting to do is that we are attempting to have the same thing in this line. You see this line here? In this line, we are attempting to have the same thing in the brackets. Because if we don't have the same thing in the brackets, then we can't come to the next step and pull out that common factor. So in the brackets, we must have the same thing, so we can then conclude that a common factor exists. So going forward here, we have this one. So we want to pair them off. Consider him our first pair. In our first pair, what is our common factor? The common factor here is x. So x multiplied by what is going to give me x squared? It's x times x is x squared. I get back this term. And x multiplied by what is going to give me minus xy? X multiplied by what is xy? Xy is x multiplied by y. So if you give me the x, and I need to get xy, what need I multiply x by to give me xy? Of course, it is going to be y. So but however, I don't just want xy. I want negative xy. Remember those rules from when we did integers, that the sign or the operation in the middle is given to that number, in this case, that term that comes after the operation. So it has to be negative. We go here again, consider the next pair. It is 5x minus 5y, positive 5x minus 5y. What is the common factor? The common factor is 5. 5 times what is 5x? 5 times what is negative 5y? So this is what we have. It's x, open brackets, x minus y, plus 5, open brackets, 5 minus y. Now again, remember what we said. We need to ensure that we get this step right. Because whatever is in the brackets here, whatever is in these brackets here, must be the same thing in these brackets here. So when we are taking out our common factors, it's important that we take it out in such a way that what we end up with here, now, here is this. We cannot violate any rules in mathematics. So as you make the attempts to find the common factor, and you're making your attempts to get the same thing in the first bracket, in the second bracket, or you get whatever you have in the first bracket, you have that in the second bracket. As you make those attempts, don't violate any rules in mathematics. However, you must ensure that whatever is in this bracket is the same thing in this bracket. That's the only way you can go down to the other steps. So, do we have the same thing in both brackets? Yes. We are saying that this here is a term. It is x into x minus y, one term, plus 5 into x minus y, one term. Here, this term has x minus y. This term has x minus y. They have a common factor. What is that common factor? That common factor is x minus y. But this x minus y, for this term was multiplied by what? It was multiplied by x. So, We have x here. And this x minus y here was multiplied by what for this term? It was multiplied by 5. Hence, we put plus 5 here. And we have completely factorized that term. Let's look at another one. 6m plus 9n minus 2pm minus 3pn. Again, that's the term we need to factorize by grouping. Some people say pairing. Sometimes you get 6 terms, sometimes you get more than 4 terms. So you have to be careful about the whole idea of the pairing. But here we go. So it is 6m plus 9n factorized by grouping. So consider the first group. It is 6m plus 9n. And its common factor here is going to be 3. 3 times what is going to give me 6m plus 9n. 3 multiplied by 2m is going to give me 6m. And 3 multiplied by 3n is going to give me 9n. Now here in the brackets here, I have positive 2m plus 3n. Look at this pair here. What need I take out in that pair to ensure that, firstly, the signs are the same? Positive 2, positive 3. Here's what. Both of them are negative. So what we are going to take out is negative something. Negative what? What is common? The only thing that is common there is p. So we shall take out negative p. Negative p is our common factor. Remember when we were doing integers, what we said? We said that when we are multiplying, this is the answer that we want to get. So we have our negative p. We need to ask ourselves now, what we multiply negative p by to get negative 2pm? What do we multiply it by? We have negative p, rules of integers. Once we are multiplying and the signs are the same, then the answer is positive. If we are multiplying and the signs are different, then answer is negative. So here, if I want to get a negative answer, my signs must be different. Here, I've taken out negative p because I want here to be positive. So it is going to be positive 2m, and likewise, this is going to be positive 3n. So we come down here again, that's what we have. And what we look here now, in the brackets, we have the same thing. We have the same thing in the brackets. So that's a common factor. We take out our common factor, that's 2m plus 3n. If I take this out, what is left? 3 here. Take it out from here, what is left? Negative p. So we have completely factorized that. And I think this is our final one. For final one, it is 5mk minus 10mh minus 3nk plus 6nh. Again, factorized by grouping. My first group, what is common? 5, 10 coefficients. So what is common there? That is going to be what? 5. And I'm seeing m being common. So my common factor there is going to be 5m. And what need I multiply 5m by here to give me 5mk? I multiply it by k. What need I multiply 5m by here to give me minus 10mh? It is going to be minus 2h. Remember, we just looked at using the distributive property, right? So consider the second pair. Consider in the second pair, what is the common factor? Common factor here is negative 3n. Negative 3n multiplied by what is going to give me negative 3nk. It's going to be k. And negative 3n multiplied by what is going to give me positive 6nh. Remember, if signs are the same, answer is positive. Check our laws, check our video on integers to give you some further guidance. And here we have common factor here is k minus 2h. We take that out. We have k minus 2h into 5m minus 3n. And that is us completely factorizing utilizing the grouping method. So factorizing utilizing the grouping method. Here's what. In mathematics, your success begins with a willingness to try. So you must be willing to try the questions. That's the only way you would know how far or how much you understand. Now, trying it and getting it wrong does not mean that you're not good at mathematics. What it means is that there are some gaps that you need to fill. There's some further research that you need to do. So I'm going to leave you with this question as we end this video. And I want you to try this question. So when we come back for the next video, I want you to provide me with the answer or your answer for this question. So see you at the next video. Bye.